Hi everyone, welcome back to my AP Calculus class. I will keep explaining indefinite integration from example 12. Let's start. Number 12, evaluate integral dy over y squared minus 4 from negative 1 to 1. This is a partial fraction problem. This is partial fractions. So change this expression 1 over y squared minus 4 into partial fraction. First, we have to factor denominator, which is y plus 2 times y minus 2, and then separate this to a over y plus 2 plus b over y minus 2. And then just make this one fraction form within terms of a and b. So common denominator is y plus 2 times y minus 2, and then first fraction it has y plus 2 but it has no y minus 2, so you have to multiply it by y minus 2 at top and bottom, so a times y minus 2, right? And the second fraction has y minus 2 but it has no y plus 2, so you have to multiply it by y plus 2, b times y plus 2, and simplify numerator. It is ay and then by, so it's a plus by, and then negative 2a plus 2b all over y plus 2 times y minus 2. That should be exactly equal to original form 1 over y squared minus 4. That means a plus b gonna be 0, a plus b should be 0, and then negative 2a plus 2b should be 1. So just to solve system of equation, so times in the first equation, that times 2 gonna be 2a plus 2b equal to 0. Then add them, cross out, 4b equals 1, which means b is 1 over 4. And then if you plug in back into the original one over these two equation, b is 1 over 4, that means a is what? A plus b negative 1 over 4. So a is negative 1 over 4, b is 1 over 4. So find the integral of negative 1 over 4 times 1 over y plus 2, and then plus 1 over 4 times 1 over y minus 2, that whole thing is dy. So it is negative 1 over 4 ln absolute value of y plus 2 plus 1 over 4 ln absolute value of y minus 2. So the 1 over 4 is kind of common. So take it out, common denominator, common factor 1 over 4 ln y plus 2 minus ln y minus 2 minus y plus 2, so ln y minus 2 over y plus 2 by the property of log. And then plug in bottom number and top number 1 and minus plug in bottom number. So you're going to find plug in 1 for y. There will be 1/4 ln 1/3. And then negative 1 for the y. So we're going to find this form. And then if we simplify that using properties of log, how can you do that? It is 1 over 4 times ln 1/3 minus 3. Ln 1/3 minus ln 3. You have to if you subtract two ln's, you just divide two numbers, right? 1/3 over 3, 1 over 9, 1 over 9, 1 over 9. That makes sense, right? Yeah. So 1 over 9 is 3 to the negative the second power. So 1 over 4 times ln 3 to the negative second power, and then that exponent can go to front, so it will be negative 1/2 ln 3. That's the answer. It is 1/2 ln 3. Let's go to example 13. Example 13 is integral tangent theta over 2 times secant square theta over 2 d theta from pi over 3 to pi over 2. It is u substitution. So which part gonna be u? Tangent theta over 2. That part is u, and then integral u times secant square theta over 2 times change dx to du. How? 1 over u prime. U prime, derivative of tangent theta over 2 is secant square theta over 2 times chain rule 1 over 2 du. So 1 over 2 is just 2. So 2 times integral u du. So u to the first power. So 2 times by power 1 over n plus 1, that's 2. And then u n plus 1 powers, that's 2. Plus c, what was u part? U part tangent theta over 2. So tangent squared theta over 2. That's the indefinite integration. And just plug in top number pi over 2 and then subtract, plug in bottom number pi over 3. If you plug in pi over 4, the tangent square, pi over 2 over 2, then pi over 4, minus tangent square, pi over 2, and then theta over 2, and then theta pi over 3 over 2, then pi over 6. Tangent pi over 4 is 1, and tangent pi over 6 is root 3 over 2. That square is 1/3. So 1 minus 1/3 is 2/3. So 2/3 is the final answer. I used u substitution. What about example 14? It is a half angle identity problem. What is half angle identity for sine? Sine squared theta over 2, that is what? 1 minus cosine theta plus 2. This is half angle identities for sine. So you can change this part to integral sine squared. No, not sine squared. By the formula integral 1 minus cosine x all over 2 dx. Find the indefinite integration first. 1/2 is the coefficient. And then what is the integral of 1? That is x. And then what is the integral of cosine? That's sine. So minus sine x. What is the two numbers? Upper limit, lower limit. Pi over 2 is upper limit. Lower limit is 0. Plug in pi over 2 first. 1/2 times pi over 2 minus sine pi over 2, which is 1. Yep. And then minus, plug in 0. 1/2. 0 minus sine 0 is 0. This whole thing is going to be 0. So what is the answer? This property, pi over 4 minus 1 over 2. This is the final answer. Number 15. Number 15. It asks you square root, d over dx integral of negative 1 to x. Do you remember the fundamental theorem, right? D over, I'm going to read right here, d over dx integral a to x ft dt. It is just f of x. That makes sense, right? So it is just f of x. So f of t is here. Integral, I'm going to prove that. If that is small ft, right? Small ft. Integral of small ft dt, let this is large ft. So this part is going to be what? D over dx large ft from -1 to x. So plug in top number, that means d over dx large fx minus plug in bottom number large f minus 1. But any numbers is a number, right? Any constant derivative is going to be 0. And then large fx here, large fx is there was a small fx derivative integral, right? So d over dx large fx will be will come back small f of x. That's why it's inside the part small f of t. That answer should be small f of x. So square root 1 plus sine squared x is the answer. We call this a fundamental theorem. You have to remember that d over dx integral a to x ft dt is always fx. Okay, let's do example 16. Example 16, same kind of problem, but it is opposite, right? X is in the bottom, 1 in the upper limit. So you can change that. Do you know that integral a to b fx dx? If you switch the top number and bottom number like b to a, fx dx, just put the negative sign, right? Because upper limit and lower limit switched, right? That's why I put the negative sign in front. So what about this part? The same thing. Negative times d over dx. Why negative sign came up? I'm going to switch top number and bottom number. Integral x to 1, but I'm going to change to 1 to x. E to the negative t square dt. Okay, so suppose that's inside the function small ft. So d over dx integral a to x ft dt, that is fx. That is fx. So what is this part? This part is going to be e to the negative x squared, because that should be f of x, but negative 1 in the front. So negative e to the negative x squared. Still using fundamental theorem. One more time. D over dx integral a to x ft dt. That should be equal to f of x. So this is ft, this is f of x. But negative sign in front of the integral because I switched top number, bottom number. That's why final answer negative e to the negative x squared. Okay, let's go to number 17. Example 17. All right, f prime of x. We have to find f prime of x. That means this is large fx. So d over dx. We have to find d over dx integral 1 to x squared, and then 1 over 3 plus t dt. So we have to find this. Yeah, prime means derivative. Large fx is integral of that function, and then large f prime is that for integral functions derivative. So I rewrite like this. It really the same as the number 17 and 15. It is a fundamental theorem, right? In d over dx integral a to x ft dt should be large small fx. That is a fundamental theorem. But what's different? In this case, there's x squared, not just x. So that is u substitution. That is kind of a u substitution. So I can solve that. I change that x squared to u. Like this, okay? So if suppose there is a small ft, integral of small ft is a large ft, let that integral of small ft dt, I'm not going to find it, just let that is a large ft. So this part is a large f of x squared minus large f of 1. Plug in top number and plug in bottom number. And then there's d over dx in front of that. So find the derivative of that large f of x squared minus large f of 1. So any number's derivative is going to be 0. This part is going to be 0. But what about large fx? That should be small fx, right? Small f of x squared. But by chain rule chain rule is what? We have to multiply it by inside the function's derivative, which is 2x in this case. So multiplied by 2x. So what is the final answer? What is f of x squared? F of t is this. So f of x squared means 1 over 3 plus x squared times 2x. So 2x over 3 plus x squared. You have to understand why 2x is in the top of the answer, because it's kind of u substitution. Because x squared part is kind of u part, derivative of u part is 2x, that's why 2x in the top. Okay, just use my way is kind of best way. Let the inside part small ft and the integral of small ft large ft, plug in top number minus plug in bottom number. So this part gonna be large f, large of x squared minus large f of 1, and then find the derivative of that. Okay, any constant derivative is 0, so large f1 gonna be 0. But large f of x squared part, this part, derivative small x squared basically, but by the chain rule, you have to multiply by inside the function's derivative 2x. That's why answer is 2x over 3 plus x squared. Okay, I solved number 12 to number 17. In the next video, I kept teaching from example 18. You practice for yourself again and again, okay? I quickly explain each examples, but after you watch my video, you try to solve for yourself, okay? Thank you so much for watching my video, and then turn on notification, click subscribe and like. Thank you so much again. Bye-bye.